In the name of God. Hi everyone, and welcome to another lecture of software testing. In this session, I want to talk about how to use JUnit again and continue to our discussions from previous lecture. In this lecture, we start our talking by running a new example and developing that. Excuse me. Welcome to class. As you see in this slide, we want to define a new class, new Java class, which named min class. We want in this class to define a method which finds the minimum of a list of integer. So the min class should return the minimum element in a list. Its parameter is a list, is a comparable list. It may be a list of integer, list of doubles, a list of characters, and so on. So we assume that our list is comparable. The elements of list could be compared with each other. So we in this list we could search an element, search a minimum element, and the return value is the minimum element of the list, as I said. And when we face to a null list or a null element in a list, we should throw a null pointer exception. Else, otherwise we should return a minimum element. And the next aspect of our class is that when elements of a list, of an input list, are not the same type, are not of the same type. For example, the list is an integer list, but there is an element in the list of another type, such as character. This in this list we have a class cast problem, because all elements of the list be of type integer except one of them has other type. In this list we could not compare that exception element, that element of other type with other elements. So in this case we should throw. And another feature of this class is that when we face to see an empty list as parameter, we should return or throw illegal argument exception. Okay, this is the specification of our class. We should implement a min class that behave as this specification. Okay, in the next slide we define the class. This is the main method of our class. We define a class, a main class, which just includes a main method, a minimum method that look for the minimum element of a list. Okay, as you see in this slide, this is the min method of the min class. The name of the class has written with capital M, but the name of our method has small m. So this is different with the name of our class in Java. As you know, the Java programming language is a case-sensitive language, so this has a different name. This method name is different with the class name. In this method, we have a parameter of list. We have a list as input parameter, which could be as of any type T. Any type T. The only condition is that the type T should be comparable. As you know, integers are comparable, float type elements are comparable, character values are comparable with each other, and so on. So this method could receive a list of elements of any comparable type. This min method should return the min element of the list, the minimum element of the list. We define the minimum element of list as type T, because we define a list of elements of type T, so the return type should be of type T. In the first statement of this method, we check the list to see if the input list is empty list, is an empty list. When we face to an empty list, as I saw in the specification, for empty list we should throw a legal argument exception. So in this if statement, we should throw new illegal argument exception for the min method of min class, because the size of the list is 0. When this condition would be true, we should return this exception. In the next statement, as maybe you know about how to treat with lists in Java programming language, when we want to read each element of a list, we should use an iterator method. An iterator method enables us to get access to the elements of list one by one. So for checking elements of a list, of this list, we should define an iterator of type T, because our list elements is of type T. So we define an iterator named ITR and set to list dot operator. The operator is iterator. Excuse me. The iterator is one of the methods of class list in Java. To read each element of list, we should use the next method of this iterator. So by the first call of this method, we could get access to the first element of the list. Okay, so the first element of the list is saved in this variable result. We define a new variable result of type t, as I defined in the definition of the list, and the first value of this variable should be the first element of the list. We set the result variable by the first element of the list and assume this could be this element be the minimum of the list. In the next statement, we check to see if result is null or not. If the first element of a list be null value, so we should return a null pointer exception according to our specification. As you see in this line, we should throw null pointer exception if list is null or if any list elements are null. We check in this statement to see if the first element is null or not. If the first element be a null value, we should return null pointer exception. And in the next statement, we have a while loop. We should check all elements of the list one by one. Okay, so we use a while loop to check the elements of list y1 and the condition of this while is that while the iterator, while our iterator has a next element, we should keep running the body of the loop. When the iterator has a next element, this assures us that the next element is not null pointer, and this is a valid element. So we set the we define a new variable to save the next element and compare this new element with the previous result to see if this new element is less than result. If this new element be less than result, we should change the result to the new element. This piece of code will be run for all elements of a list while there is another element in our list. This will be continued for all elements of the list, and at the end of this while loop, we have the minimum value in the result variable. So we return the result variable as the minimum element of our list. Okay, This is the code of the min method of our min class according to the specification of this specification of min class. We want to test the functionality, the behavior of this min method according to this specification. So for testing this method, we should design numbers of use cases. One for a normal list. At least we should define a test case for a normal list which has some elements of the same type and the list elements are comparable. We should design at least one test case for testing at the normal situation. And we should define some test cases for checking the behavior, the correctness of behavior of this method when a null pointer exception or other exceptions such as class cast exception or illegal argument exceptions should be thrown. Okay, so we have to design several test cases to test this method, the functionality of this class. Excuse me, let me see your messages. Yes, I want to run this method in a separate program. Okay. Let me to explain this example thoroughly, and after that we want to run this example in Eclipse. Let me run Eclipse program. This take time. Okay, there is another message. Okay. Let's go. The min test class, to test this class, the name of the class, as you know, is min. But the test class, our business class, is min class, and our test class has name min test class. So to design a test class, we should import a standard import. We should include that class with standard inputs of imports of JUnit classes, and then we should prepare a fixture such as a prefix setup or postfix method. The fixture that needed for this test class could be this chunk of code. In this code, we provide a private list of a string. This could be of any comparable type, but for example, in this implementation, we use a string as a type of elements of the input list. So we define the input list of the min class in this statement, and we define a setup method. We define a setup method, as I talked in a previous lecture. we use @before to define a setup method which assure that this method is run before the running of our test method, the running of any of our test methods. So in this setup method, we should initialize the input list, and we use new array list of string to allocate memory to this list. And after the, as you know, after the execution of this statement, the list is not null. But before this execution of this statement, at this point, we have a null list. So when we allocate the memory to the list by this keyword new, the list be not null list. The list could be an empty list. So this is the needed prefix we should run before calling the min method of the min class. And as a postfix, we define a teardown method by the annotation of @after, as I defined in previous lecture. For defining the postfix method, we use this annotation. So this method could be run just after execution of any of test methods of the method. We just set the list to null because there is no need to this list at all. After the execution of the test method, there's no necessary to keep this variable alive. Also, you know, in Java programming language, the garbage collector collects any unused variables, unnecessary variable. Example to show how to use postfixes in our test classes. Explicitly set this list to null. We could ignore this method, we could delete this, omit this method from our code, and this could be done automatically. But to show how to use postfixes in our test classes, we use a teardown method with this definition. The first test method in our test class is a test method for checking null list. We define a min test case to check null pointer exception, as I told about it in our specification. When we should throw a null pointer exception, when we have a null list or any elements of our list be a null value. In these two situations, we should return null pointer exception. So to implement the null pointer exception test case, we should provide explicitly a list with null pointer, a null list. So we define in this test case a list to be null, and we start to try to finding the minimum of this null list. We call the mean method of our business class, of our mean class, for this parameter. Okay. As I know this is a null list, so we use a try catch to run this method, because I know that this list is a null list, and maybe it return an exception, such as null pointer exception. Okay. If this method correctly throws a null pointer exception, we catch this exception and we return from the test method. And this is a sign that in this situation we have got that the mean method have a logical manner with the null lists, and there is no problem in the implementation of this method to treat with null list, because this method correctly throws a null pointer exception, and this null pointer exception is catched by this statement, and at this stage we return we go out from this method successfully. But if this method treats with a different behavior, treat by a different manner, and didn't return or throw a null pointer exception, we reach this position, this situation. In this situation, we should announce the failure, introduce a failure, because this method for a null list should throw a null pointer exception, but did not it, and the control reached to this position. At this position, we should introduce a failure assertion. This is an assertion. This is a fail assertion. Okay. This is a fail assertion. We write in console a null pointer exception expected. We just introduce to the tester, we have expected that the main method at this method call, at this situation, returned a null pointer exception, but it does not that. So there is a failure situation there, and we should announce it. Another test case for this method, or the mean method, is a situation in which a list has a null element. As you saw in the specification, in two situations we should throw a null pointer exception. The first one, when the list be a null list, and the second one, when the list includes a null element. One of the elements of the list be a null value. So the next test case could be as this next case, a test case. Okay, this is a test method for null element, checking null element. It checks when a list includes a null element, how the mean method treat with this null element. So as you know, by the defined prefix in previous slide, but this prefix by this prefix method, by this setup method, we define an empty list to use in execution of each of these test methods. Okay, so in this point we have an empty list, and we should add some elements to this list and then call the min method. So as you know, in this test case we want to check a null element, so simply we add a null element at first, and then we add a non-null element such as this string cat to the list. So at this point our list has two elements. The first one is null, the second one is not null element, is cat element. So we call the min method for this list to find the minimum element of this parameter. As you know, when the min method executes its body, the first statement checks the size of the list if be 0 or not. As you know, our list has two elements, one null and one non-null. So this if statement is not run, and the next statement we define an iterator and call the next method of the iterator and get the first element and save it to this variable. The first element of our list, as you know, is null element. So the result that we receive is a null, has a null value, and this if statement will be executed because the result at this situation by this test case has a null value for the first element. So the null pointer exception is thrown. Okay. So when this method is run, a null exception could be thrown. But in each of our previous test cases, we have defined an assertion. We have checked the correctness of the execution of test method by an assertion. But in this test method, we have not used any assertion. Why? How this method checks the correctness of the treatment of a min element with null element? Min method with the null element. How? As you see in our annotation at sign test, which should be used before each test method, we define the expected result of this test case. We have expected to throw a null pointer exception class. So when we define the expected result at the beginning of the test case, just after the annotation at sign test, there is no need to define any assertion, to write any assert method in the test case. There is another method of using null pointer exception as expected result for our test case method. If we want to rewrite this method without this definition, we should behave as this one. So if we delete this definition, we should use a try-catch structure to call this min method for the list, and at the end of the method we should use a assert fail or fail assertion method. Okay, so these two test cases shows how to use how to handle null pointer exception or other exceptions in our test methods with two methods, two ways. These two test cases shows two ways of handling the null pointer exception in our test methods. This is the second test case that we define for this main method class. Another test case tests a list which just have a null element. In the previous test case, we have two elements. One of them is null and one of them is not null. But in the next test case, we just check a list which has just a null element, and this could be differ from the previous test case. This test case is defined as the same as this test case, because in this test case also we expected to throw a null pointer exception as defined in the first statement, and we define a list which has just a one element, and that element is null. Okay. The fourth test case is defined in this test method for check more exceptions as I defined in our specification. The next exception should be handled by the min method of our min class is class cast exception. So for testing the class cast exception, as I talked about it, we should class cast exception check that if all pairs of our elements of the list is the same of the same type, or they are mutually comparable. So to test this class cast exception, we should define an input list with a number of elements, which one of them be in other type, in a different type, and not the same as the others. So in this new test case, we should check the mutually incomparable elements. To do this, we should define a new list which contains some elements that one of them is different with the others. As you see in this list, we have three elements. We have added three elements. Two of them are normal elements, normal string elements. But the third one is not a string. This is an integer value and not a string. Okay, so this element could not be compared with these two first elements, and this list, the elements of lists are not mutually comparable. The elements of this list are not mutually incomparable. So in this method call, we should experience a class cast exception. We could define the expected result such as this definition stated just after the @sign test annotation, or we could call this method in a try-catch structure. Okay, so this test method checks how to treat with class cast exception in the main class. And the next one checks the illegal argument exception. When we expect the illegal argument exception? When we feed the main method by an empty list. Okay, so when we call the main method of our main class with an empty list, this exception should be thrown. So in the new test case, this test case, we just have an empty list, because the setup method, which should be run before the running of this test method, provided us with an element list, with an empty list. Okay, so at this point we have an empty list, and we call the main method for this empty list. As I said, we have expected to throw illegal argument exception as defined in our specification. Okay, and there are two other normal test methods or test cases to test the main method by two normal lists. The first test check the main method by a list that includes just one element. In this test method, we have a list with one element, and we call the main of this list the main method of this class, and we expect that it returns the cat string. So we use assert true method to check if the return value of this method which is saved in this variable is equal to this string. Object equals string cat. If the return value of this equal method be true, the test case passed, but else the test case failed. So this is another test case which tests a normal list with one element. And the next one tests double element. In this test case, we have a list with two elements. The first one is the string dog, and the second one is string cat. The minimum of these two, the minimum of these two strings is cat string, because the C is preceded in the order of alphabetical order in English, precedes D. Okay, and C is less than D. Okay, the minimum value is cat. So in this min call method, we expected the return value of this method be the string cat. So in our assertion, we check if the return value equals to cat. If that, the test case passed, else the test case failed. So let me to show the implementation of this case study in Eclipse and use JUnit. We have implemented this example before, and I just opened this class, the min class. Look at this class. This is our min class, which is implemented as the same as defined in class specification in our slides. Okay. As you saw before, our min class just has a min method, which we want to return the minimum element of its parameter. Its parameter is a list of elements of general type T. T could be integer, could be doubles, float, and character, boolean, or so on. Okay, so we define the list, this list variable, this input variable, as a general list of elements. And as you saw before in our slides, the first step is to check if the list has an element or not. If the list is an empty list, if it be an empty list, we should throw an exception, this exception, else we should check the elements of list one by one to get access to the elements of list. As I told, we should use an iterator module, iterator object in Java programming language, and use the iterator method of list, such as this. And by the calling of the next method of this iterator, we can get access to the first element and save it in this temporal variable, this result variable. Okay, we assume the first element be the minimum of the list. To get confidence about this assumption, we should compare the first element with all other elements. So we should check next elements one by one through a loop. before this, we should check the first element. As you know, it's possible to be an element of this list be in another type, in a different type, not the same as all other elements. So, or be a null element. So we should check before if the result, if the first element of the list is null or not. If it is null, we should return null pointer exception, and as I explained, then we should use a loop, while loop, to check the result with all other elements of the list to get confidence the mean value be a result. If not, it should be changed. In this if statement, when we face to a element with less value than result, we change the result value to the new element, and finally we return the result. This is our mean class, which has just a mean method. Okay, and in our test class, we define a test mean class. In the test mean class, we define all of the test cases that I have mentioned in slides. We have defined 7 test cases. One for a null list, one for a null element with multiple elements in a list, one for a list which has just a null element, a list with a single element and which it is null, and a test case for check on incomparable types in a list. We should check an empty list. For each of these situations, we define a test case. And for normal situations, we define 2 test cases, one for a list of single element and 2 elements. Okay, so altogether we have defined 7 test cases. Okay, all of these test cases are implemented in our test mean class, in our test class. But before to define our test methods, normally we should provide our test class with our fixture, means the prefix and the postfix. The needed prefix is this piece of code. In our prefix, we just define a list of a string, a list variable, which is a list of a string. Okay, and then we define a setup method to allocate memory to this defined list variable. This is the prefix piece of code, the prefix of our test class. And we have defined a postfix by just a tear down method. The tear down method should be run after each test method. The setup method should be run just before the execution of each our test methods. Okay, when we want to, when the control of execution reads to each test method, before the execution of each test method, which is introduced by this annotation, the setup method is executed once, again, and then the test method is run. After the running of each test method, the tear down method, which is a postfix, is executed once to put the program state into the state which the program be in just previous the execution of this test method. Okay, so in tear down we just set the list to null to release, to free our memory, to release the allocated memory. Okay, the postfix method is defined by the annotation after. So the before method should be executed before the execution of each test method, and the after method, the postfix method, should be run after the execution of each test method. This would be handled by the JUnit runner. The JUnit runner control this rule. Okay, this is the first test method, test for null list. For testing the null list, we should define the list to our input parameter of the min method to be null. So in this statement, we set the list with null value, and we try to run the min method for a null list, and as we expected, it should return a null pointer exception. If it throws a null pointer exception correctly, the return statement is run, and we go the control go of this method, and then the tear down method is executed. Okay, but else when the min does not treat as I expected, the control reach this position, and at this position we should introduce a null exception, null pointer exception failure. This is a failure asset. And the other methods which I explained to you, all of them are listed in this test class one by one. This is the next test method which tests for null element, in which that we have two elements, one of them is null, and the next one checks a list with just a null element. The next test method checks incomparable exception or class cast exception. The next one checks the empty list, and the next test case checks a list with single element, and the last one checks a list with double element. So we are designed 7 test cases to test this min method. We check this min method, we test this min method by 7 test cases, which is defined in our test class. So I want to run this test class, and we want to see the report of JUnit. Okay, as you see in this report, you see that 7 of test case we have defined 7 test cases. 7 of 7 are run successfully. There is no failure, there is no error, and test cases include this set of test cases. The first one tests single element. When we double click, it shows, this IDE shows us which test case is this, and the mutually incomparable is this, and test for null element, and so on. Okay, you can ask your questions if you have. Please ask your question if you have any question. Please give a feedback to me if this example, if you have noticed this example. No one answer me. Please answer me. I enable your mic, and please tell me if you have any question, or you have noticed from my explanation of this example. It's not normal. You have no question and you don't got my explanation. One of these should be true, not both. Okay. You don't want to say anything in our class. Why? Why you are silent? Okay, if you have any problem, we could explain again tomorrow. But when we didn't notice, didn't got my explanation, you could ask your questions. I guess you are unfamiliar with Java programming language. It's okay. Have you any experience in programming Java? Okay. let's go ahead. Yes, you don't have any study in Java programming. You should learn the preliminary of Java, the basics of Java programming. We have not used any advanced features of Java programming. We just use basic principles of coding in Java programming language, such that its syntax is the same as C++ in more cases, most of our case studies or our classes. Examples about Java: you could search in web for any videos about learning Java, how to learning Java, and you should see just 2 or 3 hours of education Java videos. There is no need to be fully understand all features of Java. Just you should learn how to define classes, as I explained it for you at the class. How to write methods, how to use some syntaxes or structures in Java, such as if structure, for loop structure, while loop structure. This is common. These structures are common in all programming languages such as C++, C#, and Java. This is the same in all of these languages. So you should not have any problem with programming skills. And I have explained enough. I think I've explained enough about how to write these methods, these classes, and we have some other examples in this chapter which uses the programming skills. Anyway, let me keep going ahead and continue to our lecture. Another test case. We return to our excuse me, let me change some features of our test methods and make some of them fail, incorrect. For example, we change the min class, we delete this piece of code to we change this piece of code to comment, and I want not to check the empty list in the min class. So let me run again our test cases and see the results. Excuse me, why one of test cases just run? We want to run all test cases. Okay, so as you see, when we change our min method, in the min method I've deleted the portion of code which checks the list to be non-empty list. If an empty list, we should throw an appropriate exception. But when we delete this piece of code, so this min method doesn't check the empty list, and the according test case should be failed. As you see in this report, this test case is failed. This is an empty test case which tests empty list, and when we change our min method as this, suppose we want to delete this if statement, which one of our test cases should be failed at this situation? Please note that I've deleted this statement. This is which statement? This is a statement that checks a list in which the first element of the list is null. So after deleted this statement, our min method does not check the first element in which it is null or not. So which one of these test cases should be failed? Which one of these test cases should be failed? If this test case failed, this one, or I think these test case should be failed. These test case and this one. Two of these test cases should be failed because these two test cases checks the first element or the single element of the list to be null or not. These two test cases checks the correctness of null pointer exception strong. Okay, so let me run again. Okay. This statement, these test cases failed. Why this one passed? This test case should be failed. Why? Test for null element in this execution is passed. This should be failed because the first element of this is null. We run again. No, this runs successfully. This runs successfully. Why? I've deleted this statement. In this test method, we've expected that null pointer exception throw. It should return null pointer exception. And when this null method is checked in the main method, I think this statement checks this situation, and I deleted this method, but the test case executed successfully. Why? Please check this problem for tomorrow's session. Please check this. Why this test method should not be failed? Just this one failed. In this report shows that just this test method failed and not this one. I think this one should be failed because the statement of the mean method of our business class are changed so that this first null element is not checked. Please check this situation for tomorrow, this problem for tomorrow, and the next session we will explain two other examples in these slides, such as data-driven test design and using the JUnit theories. The two other possibilities of JUnit will be explained in the next session. So please ask your question if you have. If not, let me finish our session. I have another session at 12, and I should finish the lecture.